What I'd like to do next is see, do you have questions on the assignment from 6.1 to 6.3, this packet? If you could take it out, please. There was one mistake on the answer key. Right. Today's goal, transforming functions. You've been transforming functions all throughout Algebra 2B, starting from the first chapter with linear functions and all the way through polynomials. Now we will be transforming exponentials and log functions. And guess what? Everything works the same way that you've learned before. Okay? And so I'll just review. You've got horizontal translations. Because it's horizontal, it's affecting the x. So you replace your x with something. Instead of f of x, it's now x minus something or plus something. Okay? Vertical translation, something happens on the outside. Yes, ma'am. You know what? You won't actually need it. If you just want to look on with someone else, it'll be okay. Because we're not going to write anything in here today. Yep. I'm just using it to review so you know where the notes are. Or examples, I guess. I don't know. A reflection, you can reflect over the x-axis, which is by multiplying by a -1 on the outside. Or you can reflect over the y-axis by replacing x with -x. Horizontal stretches and shrinks occur inside. You replace the x with something. Vertical stretches or shrinks multiply something on the outside of your function. Okay? And that's a big idea. And it works for exponentials. You can see some examples here. Works for logarithmic functions. You can see some examples here. Okay? We're not going to spend a lot of time on that paper. What we're going to do is look at some examples together on these on this extra worksheet. So there's two examples here where we're going to graph. And then the rest of them, we're just going to be describing transformations and writing new rules for transformations. So first ones, number 1 and 2, it says, for each of the following, describe the transformation of f represented by g, and then graph each function. So first of all, before even graphing, you should be able to recognize that if f of x equals 2 to the x, and g of x equals 2 to the x plus 4, there's been a translation, how? Tori? 4 units up. Elliot, is that what you said also? Yeah, this is going to go up 4 units. And then from there, to graph it, what I do is graph the exponential, because our calculator knows how to do that. So you go to y equals 2 raised to the x. In fact, 2 to the x is an easy one. You probably don't even need your calculator. But you can make a table using your calculator or just doing it by hand. -2. 2 to the -2 is 1/4, or 0.25. -1, 2 to the -1 is 1/2, or 0.5. 2 to the 0 is 1. 2 to the 1 is 2. And 2 to the 2 is 4. And so there's our exponential function. It says graph each one, so let's start by graphing this one. I'm just going to use every unit here as 1, or every tick mark. And so if I go -2, I go up 0.25, that'd be about right there. -1, up 1/2. 0, 1. 1, 2. And 2, 4. And we know exponentials have an asymptote that's horizontal, so I'm going to make that look like we're just lining up along or reaching the x-axis and then increasing from there. And I'll label this f of x. So take a minute to get that drawn. All right, and then there's 2 ways to graph the next one. Way number 1, just take all of those points and shift them up 4. Way number 2, put it in your calculator, get a whole new table of values. But they will just be these numbers added with adding 4. And so visually, I do this. I take the 0, 1 point, and I go 1, 2, 3, 4. There's my new point. This point right here that's at 1, 2 will be 1, 2, 3, 4 will be right here. 1, 2, 3, 4. The next one goes a little bit off the graph. This point right here, 1, 2, 3, 4, and here. And there's my new transformed function. That was g of x. That's one way to do it, just visually on the graph shifting it up 4. Now, not every single function is that easy, and so if you were doing like a stretch or a shrink, it might be better to actually plug this second function into your calculator and get a new table. But in this one, since it was just a strictly shifting up 4, we can just add 4 to every y value, and we don't have to plug it in our calculator and get a new set of table values. Does that make sense? Cody? Okay, so say I didn't hear the whole thing. Okay, in this one, close. He's saying in this next one, instead of going up or down 4, he says we're going left 4. But what are we doing? We replaced the x with x minus 4. So when we do something with the x, it goes the opposite of what you think. So actually, it's going to go to the right 4. So notice our x got replaced with x minus 4. That means it's been a horizontal change, opposite of what you would think. And so right 4. And so when I do this, I'm again going to use my calculator, e to the x. You don't need to see my calculator. Y equals e to the x. And then I get my table of values. -2 is about 0.14. -1, about 0.37. 0, 1. 1 and 2.72. 2 and 7.39. And that's usually enough points. You get about 5 points. You should be good. And then I'll graph those points. So if I go -2 and up 0.14, it's very close to the x-axis. -1 and up 0.37, not quite halfway. 0, 1. 1 and 2.72. And then 2 and 7, 1, 2, 3, 4, 5, 6, 7.39. So just above where my graph ends. And then horizontal asymptote increasing. And this is f of x. Now to get the second function, feel free to just shift every point to the right 4. Like this. Here's 0, 1, 1, 2, 3, 4. The point 1 and 2.7 something, 2.718. Go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then there's my g of x. If you don't like doing it that way, you plug this other function, g of x, into your calculator, you get a table of values, and you plot those points. Okay, questions on graphing?